Good afternoon, everyone, and thank you for my colleagues for a very interesting and captivating panel. And we will definitely continue with a very interesting topic. I would like to welcome here Oliver and Ric, very interesting guests who have both very interesting topics to offer. A few words about Oliver. Nothing less than a commercial application of space data and AI, and Ric here, very hands-on, very real, very happening research and space project in his hands. So why don't we go right in, give Oliver and Ric a couple of minutes to introduce what they are up to right now, what their projects are like, and then we can move forward.
Hello. Thank you, everyone. It's always glad to be before the lunch. Hopefully no one is hungry. Yeah, so about me. I'm a head of space domain in Datel. So Datel is an Estonian software company. We are specialized in creating geoinformation systems. We are roughly 100 employees. And we have been building this kind of geoinformation systems more than 20 years already. Most of the core Estonian geoinformation systems like cadastre management, address management system, land tax, and so on are built by us. And last 10 years, we also have been processing satellite data. And for that, we started with a product called Sille, which is infrastructure monitoring solution. So what it actually means is that we understand movements of buildings, dams, bridges in a millimeter scale. So for example, if this house from one side goes down 10 millimeters, we are able to detect it just from satellites. But this is not the only product which we are building based on the satellite data. So our most recent one is to help municipalities to detect illegal constructions. And for that, we are using also the machine learning, computer vision, to really make efficiently these kind of detections and help municipalities to find the objects of interest for them. Yeah, so I think this is kind of short introduction from my side, what we do and who we are. Thanks.
Thank you, Ric.
Thank you. Yes, I'm Ric. I'm one of the PhD students at the Tata Observatory in the Space Technology Department. I'm the lead engineer of the KuupKulgur, and in my research, in cooperation with the European Space Agency, we evaluate different processing platforms to enable artificial intelligence actually in space. So what we try to do goes through the entire bench, from a task complexity of any kind of task to how much power, what kind of devices do I need. And the results of this work essentially allow us then to take choices for the lunar rover, for navigating on the moon. How can we navigate? What can we actually allow? Can we make the rover actually autonomous? Or we can do, of course, in the scope of where my PhD actually originally comes from, in the scope of the ESA Combat Interceptor mission, we have the Estonian instrument OPIC, where we basically can observe through the camera a pristine object or a new object which comes from the outer solar system, which we see the first time, and we want to crop this down. We have a simple but appropriate solution to do this right now, and one of my PhD research questions is to how detailed, how good can we do this in the future? How much can we reduce the data so that we get, with the same amount of data, so the same data size, more information down to Earth? And that's basically what we're trying to answer.
Thank you, Ric. I will come back to you. I have very many questions towards the software you are trying to, or sending up to space, also the hardware you're sending up to space. Likewise, Oliver, it's very interesting. You can detect how the Earth moves, how the big constructions move. Very many potentials there, I see. But so while you are using space data, terrestrial space data, for your business applications, whereas Ric is bringing the software up to space to gather new information. I would like to ask you about the AI application for both of you, because you both use it, you both need it, but where does an AI begin for you actually, and where do you use it in your projects, and where does a sophisticated algorithm actually would be even more beneficial for you? Because in fact we are not, I think everybody in the audience also is on the same opinion that we don't do AI just for the sake of doing AI, but sometimes we also need to have just a very robust algorithm. So please.
Yeah, so it's with this area where we live in large language models and everybody talking about AI, it can be quite easy to forget that AI isn't a goal itself, it's a tool to achieve something. And it's a really powerful tool, at least for some cases, when we as a remote sensing company, we're talking about computer vision algorithms. It's by do it a rule-based system, it's like very hard or even not possible at all. So for this use case, it's really beneficial to use this machine learning to actually read out the interesting objects with this machine learning algorithms. It would be very difficult to do it otherwise. But for some cases, when you're still in paper processes, you don't need to think right away that, oh, we need the AI for that. You need to solve the real business problems, and in order to actually apply AI in a high level and really beneficially, you need to have the data first. So if you are still in paper, start with digitalizing, and then you are actually gathering data, and you can start doing more advanced predictions and so on with AI. So leave the AI for things that it is very good for, but not try to put it for everywhere. That it's a tool, not the goal itself.
Yes, absolutely. But in your work, in your everyday business, while you are observing a large scales of terrestrial info, or large territories or areas or cities, where would you use it? Where would you opt for the AI solution, and where would you opt for an algorithm? In which situations?
Yeah, for us, I said computer vision, when there is images, when you're using optical or radar satellite images, for there to detect something that is interesting for you, it's a very good place to use machine learning. But actually for then other product which we have, this kind of scientific methodology, how to get this kind of info out, is also a very, very good way to do it. So it's there is, you can do really difficult things also without AI, but yeah, some things it's hard to do without it.
Yeah. So is it true that sometimes you may need even more larger data sets for working on your algorithms rather than training and deploying your AI model?
Yeah, you can say it like that. Yeah, if you don't have the data which you can train the AI model, then you are in a difficult situation. Of course, yeah, the large language models, they are getting smarter and smarter, so they can be more universal. But usually, for specific cases, you still need to train your own model, specific model, to solve your own problem. But we'll see what happens in 10 or 20 years. But I myself strongly believe that there's still needed specific models because the universal model can't solve everything. But this is we'll see what the future brings.
Absolutely. So Ric, when would you go for a neural network, and when would you go for an algorithm?
So yes, it's a very good question. It's basically what I try to figure out every day, is to figure out from what task complexity is a traditional algorithm not anymore capable to do and to fulfill the tasks.
So we're getting your PhD now in 7-minute summary.
So essentially on OPIC we have a so-called, we call it blob detector, so it can detect the blob and it will select the comet as a traditional algorithm. It's very simple, but it's also very reliable, very robust, because it captures so much. But if you would have increase the complexity to multiple objects and more you want to crop it more precise, your algorithms are going to run out of capacity, what we call it, like skill, if you want to call it this way. And then normal algorithms are either not any more capable for it, or it's going to take too much processing power. And that's where we try to figure out in a neural network, when does a neural network become actually useful, or an AI in that sense, or another method actually become useful and overtake the traditional algorithm, and is there even a sweet spot in between where I have the same power and the same complexity what I require and can still do the same things? That's where really the question lays. This is a very good question. And for vision algorithms, when we talk about domain specific, when we talk towards the moon and so on, traditional algorithms tend to be more general. You also need to manually tune them often. Do you have the data to tune it accordingly, or do you have actually more data to actually specifically train it towards that? So it's a really balancing act which you have to figure out. For onboard processing, I hear very often still that traditional algorithms are very often being used on board spacecraft because it's just much more efficient, and the task which they want to do right now, they can do, but we want to do more. And we always want to do more, I guess. And we want to get the data more compacted and those kind of things, and that's where the AI will come into.
Absolutely. So if I rephrase it, then for you, you would go for AI in situations where it can do better than you, in some way, better than the previous or more standardized working methods have been providing you before.
Yes.
You would go for it.
This is exactly one aspect, but also there's certain neural network architectures or AI models. They can be very widely used. So you actually can make one approach very efficient, but you can use them when retraining and restructuring them, but you can reuse them, and that is easier possible than developing a new algorithm entirely from scratch. So it's something where we can push really the boundaries of what can we do next, because right now we're reaching, with some methodologies, at least the limits. And that's what we're trying to see how far we can get with another approach.
Absolutely. So why don't we jump right into the secret ingredient, what we need for our AI applications actually to bring that added value we're looking for. How do you train your data?
Yes, the data is always the question. In reality, in artificial intelligence, nothing is going to work without any data. Like, we need data, and when we talk about exploration missions, we're going towards targets we have not seen, or we have only seen similar objects. So what are you going to do about this? That's a really good question. So there we go into synthetic data generations. Of course, we have traditional tools, more like Blender, which go very high fidelity, but also even gaming engines, Unreal Engine 5. Probably many have started to play games with this. This is something where we really push the boundaries of creating new data for our applications. That's for the lunar data, or for Comet Interceptor, we're using Blender, and that is really high fidelity data. And what we do here actually is we do not think only of one scenario or what we try to do. We try to get it as similar as possible as we imagine it. What we also do is we create data which is just seemingly random. So if we talk about a comet, we do not know which shape of a comet we will see. And hence we might do a spherical shape for comets as we all know it, but also we have seen, I don't know who knows, but we had an interstellar object coming which had a really elongated shape. And then we have to imagine and we have to push the boundaries. That synthetic data generation will really allow that. And this will create so-called noise to later be able to detect anything which might be in the scope of our target. So we don't miss anything out.
Absolutely. I find it very fascinating because in effect you are, at least with the Comet Interceptor mission, you are going to launch your software to the space, recording, but oftentimes you're going to record and look for something that you don't know what exactly you are looking for. Okay. So it's maybe a little bit tricky even to know if you have found it.
Yes.
So I'm curious how it will turn out if you manage your AI to give you analysis that will be of scientific value for you. But there's a good question in this realm as well from the audience. So it says that the cost of error during the space mission is large, and AI can hallucinate and give away wrong answers. How do you prevent AI-caused mission failures?
So there's a we classify AI application into two domains. We split it into mission critical and non-mission critical. What we're talking about here is payloads, instruments. They're scientifically valuable, but they are not necessarily mission critical. On the AI side, on the satellite operation, where it's going to fly to and how it's going to fly, this is much less AI focused right now. This will come. But in the payload domain, we will always take the more conservative approach. So we will just include more data, and that's again where the trade-off comes in. Do I just do a blob detector because it's general enough, or do I want to push the boundaries? And right now we are not there yet to push the boundaries for beyond just doing a blob detector, but that's where we're trying to figure it out. And again, that's where the data is also very relevant, because we can kind of create any scenario, and we can see where is our limit. This is what the synthetic data is about, in which scenario will my mission actually fail? And of course, this is more like a preventing of just being general, very well understanding. And to be honest, not only AI will miss combat, which we have never potentially seen. Other algorithms will do the same.
So very careful deliberation, what you put where,
trying everything
and how
out. Yes.
we will be following your results with great interest, Ric. Especially we're going to read the fine print, what you added where. So
yes.
Give us a high five when you're published. But Oliver, you have also very interesting use case for the space data, and how you train your models, and all the complexities and challenges perhaps that are resulting from there.
Yeah. When we're talking about application based on the satellite data, so in order to have the proper training data, you can say that there's kind of four maybe the most common ways how to get it. So yeah, and first of all, there's like two parts of it. One part is the satellite data itself, like where you want to do the recognition, and the second part is like objects that you are interested in. And these have to go in combination.
Yeah.
And the most simplest way, but also time-consuming, is that you take the satellite data, human goes through it, and labels the objects of interest that you have. It's time-consuming, but also a lot of used, very also effective one. Then there's also some existing data sources, like some registries and information that has interest of objects there, and then you have to combine it and process it in a way it would actually work on a concrete satellite data set. Like the house looks differently from the resolution of 10 meters or like 30 centimeters. So you have to like process and make it work. And of course, there is also this kind of this kind of data sets that already processed. Like Google has, for example, this kind of marketplace for that. You can actually have this kind of already ready-made data sets. But what is also an interesting place where it goes to the fourth one is that you actually are able to kind of create or simulate. Like for example, when you have like garbage dumps, it's hard to have this kind of concrete data set that like we know that garbage dumps are there, and now just let's label it. But there's also an option to actually simulate it, to try to put these garbage dumps on different satellite images, and then actually use this kind of created, simulated data sets for training. So these are these four main options how to create these data sets to use for creating your own AI.
Yeah, very good. I mean, synthetic data seems to be getting more and more interesting, because we are trying to do new things, and we need to have something to train on, right? Exactly. Let's pretend we have on the stage a genie in a bottle, in a very good mood. What would you ask him?
I think for us, when we're talking about working on Sentinel data, you have the access there, that you are able to receive all the data, but it's still a 10-meter resolution. If you want to do something more advanced, you need to have a high resolution satellite data. And of course you can buy those, but if you really want to train a lot of huge models, and actually maybe just test out things that, are we able to see these objects from this resolution, or how well it is, it would be very useful for us to have this kind of access to this high resolution data sets also, that we are able to like not always go and buy, but for like training purposes or this kind of purposes of understanding what we are able to do or what we're not to have this kind of easier access to those would be also great benefit for us if you're gonna have the genie here.
Yes, genie. I think we'll get the genie here next conference. But when you were talking about the better access in terms of money also, but also perhaps licensing, or what are the different perhaps arguments that are right there on the market at the moment?
Yeah. So there are several parts. So the one part is that when you are want to create your model, and second, but usually the model itself, it's for technical people, oh, it's nice, let's train a model, but in the end, the model itself is not only value itself. It has to be actually put in a place where it is useful for your customer in their business processes. So it usually also means if you actually have to integrate your solution to their existing applications, or you build your own application around their business process to actually help their business process. And in order to do that, with high resolution data, there's always this kind of licensing questions to come up with, because usually the high resolution data providers want to resell the data. Like even if you are tasking that, yes, I want to this area to buy this, have this data, but it doesn't mean that actually you get this data in a way that you can do whatever you want with that. There are still licensing terms how you can use it, and it's mainly because they actually want to resell it. Like if somebody else comes and say, I want exact same time, same data, then they are able to resell it. So this is like their business model. So have this kind of also some kind of like data of high resolution data, which would be like off from this licensing complexities, that you could do whatever you want with that, and there's no restrictions on that part. That would also be helpful for like creating new things.
So there's a tiny plea to ESA to make more good stuff available for us, potentially, yes, respecting, of course, the interests of all investing parties. Let us look at the question we have from the audience. Let's see if it works for us right now. Okay, well, I think we kind of answered it.
Yes.
How do you get an organization to actually share their data so that AI algorithms can be actually trained? Ric, where do you get your data from? And also, if you had a genie in front of you, what would you ask?
Simply put, if it's not already there, they don't. There is, of course, there is some open source available data, but it's very limited in many scenarios. In the science community, we have actually data from, for example, from previous comets, from the Rosetta mission, from DART, from Hera, which just recently launched. We have some data, but in our case, it's very, very limited. It actually doesn't even exist. In other cases, for other applications, it's very much licensed. So I cannot even ask anyone, so that's kind of unfortunate. Also, even for lunar data, it's also scientific as much as available, but then it's not annotated, so it's not by anyone labeled, and that resources have to be spent on that. So that's something which is, of course, and that's why we're going towards synthetic data, because we can do all these kind of things automatically then. For the genie, telling me what devices are most efficient, and I have my PhD done. That would be probably good, but also it's a constantly evolving thing. So when you ask me now, or a year ago, or in a year, this kind of question evolves very rapidly in this domain, and that's very, very difficult. It's for myself, there's not the one question actually which I get, and then a year after the same problem again, I would need another wish. It's going to be quite difficult.
Absolutely, because the audience also wants to know how do you deal with the energy constraint in space?
Yes. That's the big question which we have. In my research, I look into different methodologies. You have multiple solutions, or you can use different methodologies. What you either do is reduce your performance, so you do not need to go as fast on your processing, for example. This will reduce your power consumption. But if we talk about ChatGPT, I don't know how many cups of coffee or how many Google searches one response requires. This is like multiple of those. It's not something which we can do right now, at least not on a small satellite mission. So we have to be really focused on our applications. Like, do we want to, when we have a navigation, do we want to do obstacle detection? Do we want to do navigation, feature detection, everything in one? Or do we just need one more narrowed application? And to do one more narrowed application will make it more efficient, despite the technology development, which I look into, of what kind of chips I have. So is the task complexity, really understanding how complex of a task can I do, and what can I cut out? What do I actually have to get my results? And of course, that's the big question which we ask on board spacecraft. How do I deal with the power? That's the big question.
Certainly, and this minor question of having things not breaking down for you in the space.
Yes, that's the other part. Like when we talk about commercial GPUs, which are on the service from Microsoft or whatever, these GPUs, when we put them into space, they would be gone within a year essentially, not going to have their performance anymore.
So if you touch upon a little bit that the Comet Interceptor mission, which is ESA-founded mission, and Estonia will provide a crucial element to this mission. I suppose this robustness of this technology is also one very key issue that you're dealing with.
It's especially in those missions. These missions are Comet Interceptor is going to launch in 2030. It's going to at least have 5 years mission timeline. So you're talking about this, or in other missions you go into 10 or 20 years, and there you go for certain types of hardware. And that means I cannot use the most novel hardware. I need to find other solutions to enable as much as possible. And we're working with devices which are 20 years old just because they are known to behave in space environment like this, and they do not degrade. And that, of course, then when we say right now, oh, we can't do everything algorithmically, that's not even my problem. I cannot even run the most advanced algorithms in space, and that's a big question, how to resolve this.
Yes, absolutely. So the time frame for this mission is 2029.
Yes.
Are you on time?
Yes.
Very good, very good. Skipping back to the questions from the audience, I think this one is for you, Oliver. Sovereignty seems to have finally gotten momentum. However, this has a price. How can private space organizations scale their AI capabilities while not relying too heavily on public funding? Okay, sorry, maybe either one of you feels that it's more towards them.
Yeah, I can address it also. Like, the current status quo is that I think there are none companies in space domain that has no dealings with public money, and this is the de facto status. Of course, it's not the ideal way. It should in the future be able to run without just as commercial basis, but. The question is when or how we're going to get there, because if the problem is that if there wouldn't be this kind of public funding in this sector, it would be probably reduce the number of companies who are actually dealing with that, because the risks are higher. Of course, we can debate if it's a good or bad thing, but this would be probably the result. But I think there will be more in the future still companies where you are able to do things without this kind of public funding. If we talk about these data sets get more accessible, you are able to find this kind of places where to use it, because there's a huge potential for actually using this data to improve the business processes. And in the end, it's not just the satellite data that can solve everything, but you're actually integrating it within the business processes. This is the core thing that actually brings value for the end user. And for that part, if this kind of pre-processing or this kind of pre-object detection or everything, this is much easier already to do. There will most likely be more companies who will be actually start working with this, integrating it inside the business processes of the end users, and this could be done without heavily relying on the public money. But yeah, so there is I don't have a clear answer for that, to when exactly and how, but I see that it's realistic that it will go for more on that direction, at least for some parts of it, of the building applications on the satellite data.
Do you want to add?
There's the especially public sector is a catalysator, so it will reduce the threshold to do things. In the end, hopefully, we have like a private sector. What also, just to add on this, what I see as a very important factor is like double use, triple use of applications. So if we talk for common industry, we try to do a flyby, a very fast object. But there is also, we got approached by companies for rendezvous and docking, because they have a very similar behavior. They want to process a different scenario at the same speed. So these applications can be used in the different domains, might even be relevant for terrestrial applications in flybys of objects, in drone interacting and controlled airspace. Those kind of things might be relevant. Or on the lunar rover side, we actually have a cycle almost, so we put your terrestrial offload applications onto the moon, where we learn maybe to become more efficient, which we then can put onto the terrestrial application to then make, and this will lower the cost because there comes funding from different domains in there, which then pushes our technology development further, and then hopefully we get the cost significantly down over time.
Thank you. This is actually a very good mentioning. It brings us to the further applications and also the financing of the research you're doing, and also creating alternative and new business models, of course, from the applications you already have, from the data you have, from the programs you have. Either one of you, maybe Oliver, do you want to elaborate on the further, well, as much as you want to share with us, of course, but on the further business applications you see are possible in 5 years' time, in 10 years' time?
Yeah. I'm looking in a context of this kind of basically building an application based on this kind of satellite data that is gathered. And what I see is that there are right now a lot of satellites and a lot of data gathered. We're talking about data that's public accessible, but also like the private commercial satellites, and there are more and more going up there. And there's like a huge potential in there because the data that is gathered and how it's actually used in the places where it could be used, there's a huge gap between there. What I believe is that in like 5 or 10 years' time, to have this kind of like this satellite data integrated in your like business process in a way that you might actually don't know that there's actually a satellite data in there, because you just give the information, like for example, okay, you should go there, there's a garbage dump, somebody's dealing with that, somebody's putting some stuff there, just go there. They're giving you this kind of just coordinate, go, and you don't even like think where this information actually came from. I think it has a huge potential to grow, but yeah, I think for the concrete this kind of cases, there's no point of currently sharing that because there's so many of them, so it's hard to really predict what will be the most influencer thing in 10 years, but I believe that there are several places where this will be part of this kind of regular work, business process in 10 years. So it will much more come to this kind of real daily life for many people.
So very swiftly integrated space data into your applications.
Exactly.
Yes. For example, when today we can follow the infrastructure, the slightest moves in the wrong directions, for us very valuable.
Yeah.
Potentially we can save lives with this knowledge. Right now we can save costs with this information. So if we now multiply this for the 5 or 10 year horizon, this is going to be a game changer, I believe.
Yeah, for example, like what we have done more than this kind of 3,000 this kind of inside analysis, which is this kind of information monitoring analysis for us. And what we see, this kind of pattern, is that there is when there's large construction activity going on, and then it not always impacts the nearby buildings, but there are a lot of cases where it actually does. And well, this could be one example that if you're actually starting this kind of large development, that you actually have to or need to monitor it with satellites to make sure that if some other nearby buildings start to be impacted with that, then you get alert and you are able to, like, for example, stop pumping water from the construction site to make sure that it wouldn't impact actually. So this kind of in this example, it could or should be integrated to this kind of object manager of the construction site. And I think this is the trend where it goes to.
Absolutely, absolutely. And if we think about alternative uses, okay, we are not touching upon the dual use of any of these technologies yet. In civilian sphere, there are many ways how we could benefit from it and let's say rebuild areas that are destroyed or contaminated or polluted, etc. Ric, do you also see any potential for your technologies or for your softwares in that realm?
And so into the future, we of course talking always about long-term missions here. So we talked about the time frames for lunar rover, like towards in the 2030s, something like this, and for Comet Interceptor as well. So we're right now developing the next generation, which comes after this. And this, of course, is where you push really the boundaries. Space application technology in general have returned significant things, also little things, like a shaving foam has been improved a lot, actually on the ISS, for example. And what we can do, hopefully, is that we can have like a double or multi-use, what I'm always thinking of, and that's why I got into the domain. When you send your rover or your project to wherever, we do not know what we will see. And what we try to figure out now, or what my question is always, how do I actually recognize something which I do not know?
Yeah, you don't know what you're looking for.
Exactly, and what I look for, and when I search for anything which I do not know, how do I get that? Because I might just filter it out as noise. This is a very big question. And when I improve those kind of task approaches, this is definitely something which is universally useful for many applications. I can, if I figure this out on a low power scale on board a spacecraft, I have a really high reliability at a low power with a high task complexity, then I can put this also definitely onto the ground and can get can then get responses on drones where I do not want my drone suddenly to fail and crash or my car to drive into anything. And of course, that's where I think the overlap in the end comes. These kind of things also eventually at some point there will be neural networks, and that's a trend which already evolves now, will be onboard spacecrafts for Earth observation. So potentially in the future might be satellites which observe exactly or do exactly analysis or run the neural networks and might send the alerts directly down and might just run through the server on the ground where less processing happens. And that's where everything kind of ties together. Every kind of boundary we push a bit will hopefully when we look in the right way, will be useful in other ways as well.
Absolutely. So I see that the potential is there. Absolutely. It's yours to harness. We have a couple of minutes left, so I think we can see a couple of questions from the audience. Can we move back to the previous question that we had? One more. This one, yes. So, good quality data is paramount. Do you evaluate the quality and traceability of data used in your models? And when lacking, do you leverage GAN?
Like, of course, the data quality is everything, and this is our everyday job to make sure how high quality it is and how we could improve that. So yeah, this is a short answer. Yes, we work a lot with that.
Very good. Shall we take one more?
For adding for the guns to answer this neural network-based data generation approach. And the problem is that we discussed it with other people before, is neural networks are extrapolating things. So their prediction out of what they know, a gun will do pretty much the same. So for getting more data of the same type, yes. If you want to open a scope, no.
Okay, very good. So one more. Industry leaders like Planet have recently laid off a significant part of their headcount. What can we learn from it to avoid similar pitfalls in Europe? If you want to comment, you don't have to comment unless you find it okay.
I think here, like in Estonia, we have more maybe it's wrong to say, but this kind of down-to-earth thinking is maybe quite common here. So for example, if you raise investment money, the question is like, is the adding the headcount itself a priority, or is it actually this kind of priority to solve some problems, and you need then people for that? But if the headcount itself, it's like goal itself to raise a next round of investment. So this is why this kind of things happens, I would say. But I think in Estonian field, I'm not saying it's idle, but I think we are much more down to earth in that day, that we are thinking first before just hiring for hiring, not to actually do some real and beneficial work.
If you scale quickly, you go into the risk that the next project or whatever you have will not run as well, and then you have to scale back down. That's just the reality of this.
Yes. Do we have one more, or maybe we have gone through all the questions? Cyber threats. Are we up to it? Is the AI labeling data collection itself a cyber threat, enabling certain attack vectors? How to avoid this problem?
Yeah, I think it's a very interesting topic. Like, I don't think anyone has this kind of concrete answer. Like, this is the solution for the problem. But I think this is a trend that is happening. Like as previously also talked about, this generating data, and you can use also AI to generate this kind of data. So I think the thing is that this topic will be more topic in 2-3 years. People are actually talking about how it ruined something or made something really weird happening, and I think it's a future. But how to avoid it? It is very hard to tell a concrete solution. But of course, if you first thing is have to realize that this could be a problem, and then you can mitigate the risks based on that. But of course, still have some kind of truth data that is labeled by a human. It could be one way to do that, or have this kind of quality checks in place by human. But in the end, when you're comparing the AI capability to create labels or this kind of training data, comparing to human, like it inevitably will go that way, that the AI will start doing that in some way. But the question is how far it goes, and what will be still the human role to check it and recheck it, basically.
There's also essentially the problem is when you have a network, a generating network, maybe someone manipulates this or has manipulated the data you feed into this, and then of course your predictions get a bit off. And that's something which will evolve in the future more and more. There's two things which you may want to do or consider. One is explainable AI, so understanding and trying to make the AI transparent so you can actually at least understand something of it. So where does it come from? How does my training affect it, and those kind of things? And the second thing is actually testing your data against real data. We do this in various scenarios. We actually use Apollo data, Rosetta data. Even in science you can do this. So you will have some data where you can apply it to, and then you at least should be able to get the vast or the big problems you should be able to avoid. If there's a very subtle and minor thing, this will always be very difficult to find.
Yes, absolutely. So I believe really that we have to, if not for a very long time from now, perhaps always, we have to combine the artificial intelligence with our own intelligence and the knowledge we have. Ric, what is the key takeaway for you, or what would you like to pass on to the audience as a closing remark of this panel?
That especially when we explore and we push the boundaries, those kind of things can really benefit in many, many ways. Where we just need like novel approaches, we need to think out of the box. It's nothing which the exploration or whatever we do will never be like commercially viable, but we will learn things which will just apply to many other domains.
Thank you. Oliver, the last word is on you.
Thank you. So I think from my side is that I see a huge potential for using the AI in Earth observation, but I don't think we should stop in that place that, we just use AI for that, but we also need to think how these new opportunities will change the business processes, what actually matters in the end. So not think that, how we're going to just build a greatest AI for detecting some objects from satellite data, but to really think further in that context, like what would it actually mean for people using that, how they could actually really benefit it and make it as convenient as possible for them.
Thank you. And this is the end of our lunch.
Thank you very much.
Morning session.
Thank you.